the cost and various ways in which you can do a cost and a time optimization. And the core of the session would be in terms of engaging with manufacturers. And a second, the follow-up session would be focusing more of getting factory ready, your documentation and things like that. With that, I would like to introduce G. So G Key is partner and program director at Hacks. And as program director at Hacks, G is responsible for driving the content and delivery of the Hacks Seed Accelerator program in Shenzhen. He oversees all elements of recruitment, application review, due diligence, curriculum development, mentorship development, and program execution. He also provides ongoing mentorship and support for the teams who are part of the program, as well as the Hacks alumni. In terms of background, G is a mechanical engineer by training and who comes to Hacks most recently from IDEO. He brings with him a unique combination of experience in factory automation, product design, and high-speed machinery. He's skilled in designing complex mechanisms for a wide range of industries, and his patent portfolio includes industrial machineries, air compressors, diesel engine components, etc. Welcome, G, and thanks for coming on to this webinar.
Thank you. Thank you very much for having me in this afternoon. So thank you very much for the introduction as well. And for this session, I was told that so choosing manufacturing and preparing for tooling is very important for the audiences in this webinar, right? So it's my pleasure to go over some of the choices you're going to make during your manufacturability of your products, and also more importantly is probably how do you engage with manufacturers and ultimately choose the right method to produce your devices, right? So I believe that most of you in the audiences are very software heavy, but hardware is an enabling factor to enable the software deployment. And same as Hacks investments as well. So most of our investments are extremely software heavy. However, a lot of times they fail. It's not because of software, not because of business, not because of founders, because that manufacturability and producing the hardware that it requires is more challenging than expected, right? So in this presentation, I have some learnings from failures from some of our investments, good practices, and then hopefully it's going to be useful for you guys. So I am quite flexible in when you ask questions. I know over Zoom, it's very hard for me to see who's asking questions, but feel free to interrupt me by audio, or I believe I have 10 minutes, 15 minutes at the end of the presentation to take any questions. Okay, all right. So just gonna say a few words about Hacks. We have invested more than 270 startups already, right? So it's coming anything from FDA Class 3 medical devices to robotics, to consumer devices, or to industrial applications, industrial machineries. And we are investing from 3 locations. Shenzhen is where I'm at, San Francisco, for where the investment's at, and Tokyo, where it's B2B connections located. And we are in the intersection of physical and digital, right? Like I said, that a lot of you guys and a lot of Hacks teams are focused extremely in the digital side, but the physical is the enabling factor, right? So what does it look like? Well, if you combine, sensing, automation, materials, life sciences with cutting edge, machine learning, edge computing, machine vision, you are in a fantastic place to disrupt some of the most traditional industries, right? So we've been investing a lot in mobility, food, mining, facility management, connectivities, etc. And I believe that there's an intersection between what we invest in and what you are doing. And so our learnings from this kind of investing in these industries, hopefully, is going to be quite relevant to you. So the way we help teams is that we invest, and then the startups come to one of our locations for up to 9 months, and then also drive a community of founders, advisors, partners. So I'm very, very glad that we have you guys as partners from IST and Intel, and looking forward to work with you guys, work with the teams, and for you guys to also work with our teams. So with that said, let's go over the main presentation for today, which is going to be on the manufacturing methods, and then specifically injection tool and die, and going to reserve most of my time on how to find manufacturers and how to engage them. Right. So to start, and this might be a refresher for the mechanical engineers in the audiences, which is some of the list of manufacturing methods which startups are able to employ, right? So, and then really when you decide that if you have a part you want to injection mold, or you want just purely CNC or 3D printing, is a lot of it depends on what do you design, how do you design it, and what do you design it for, or what the volume they're looking for, right? Or accuracy, etc. I will just go over some of the list of the tooling methods that some of our startups employed, and then the pros and cons of each of them. And then to start, of course, injection molding, right? A lot of startups, when they approach to hacks, when they approach to early stage before they have funding, they are very worried that tooling cost, right? And then when you talk about tooling costs, really the big thing is about injection molding, right? You can, if you only have an angel round or a seed round, it can take significant amount of your tooling cost. And then injection molding have shifted into a bit of a low cost and software tool to accommodate, the decreasing volume of products that's been manufacturing for the past couple decades. And then there's been some quite powerful tools for you guys to employ for the injection molding of your devices. Of course, that injection molding require a relatively high volume of tools to make financial sense. But most hacks teams, if they do need injection molding, is done with simple angel money. So the tool that you're looking for is probably, if you're looking at for 10,000 devices or below, is called P20. P20 is type of steel that is extremely cheap right now. So, and they have a very fast turnaround times. So roughly runs about $3,000, and you can have a set of tools like that. So the size about 60 millimeters to 50 millimeters thick, those kind of parts, with couple of sliders, and then that's perfectly fine, right? A lot of teams do use silicone molding. So in fact, that most startups, before they go injection molding tooling, they will test with silicone molding. Those are also very cheap, very quick, but it does not last very long. So silicone molding usually lasts for 100 pieces, and then the cost can be as cheap as 500 RMB. Our 500 RMB is roughly $70 for a set of tooling. So we have a team called MS. So they made a whole robot with silicone molding as a tool, right? So you have very precise components inside that's still silicone moldable. Each mold only make 10 pieces, but that's enough for their early stage production. We have when you're working with these kind of tools, these kind of products, right? Canister type products. A lot of industrial process teams do have these. They will require hollow plastic parts, containers like that. Surface finish can be a little bit of on the rough side, but it's extremely cheap at higher volume for with internal large cavities. Right? And this can be quick as 7 days to do the turnaround time for the tooling, and the unit cost is extremely low. And then vacuum forming, when designed creatively, vacuum forming can be a fantastic tool, right? In fact, that's how most of our suitcases are made right now, or those PC suitcases. So a team called Living Farm, they make those incubators for worms, for food, edible worms, and then each of those canisters are made of vacuum forming, significantly decrease the cost, right? So if we and then the surface finish is rather good. They want some design awards based on this kind of design. So aluminum chassis with vacuum formed casings, and then significantly lower the cost. One idea, one manufacturing method to consider for you guys as well. Forging. Actually, let me go back to this. I think my PDF have did not skip the slides. Did not skip the slides when I print them. So I'm just going to go back to the Google Sheet. So So I'm going to skip forging because it's not very widely used, but die-cast is. So die-cast is one of those things that tooling is quite a bit, but the quality and then the performance of the parts of the metal parts coming out of it is fantastic. And then sheet metal. So I want to spend some time on this because a lot of you guys are doing robotics, and robotics at low volume, sheet metal is a lifesaver. So
Sorry, I'm not able to hear now. I'm not sure if G. G, somehow we're not able to hear you. Can you just check if it is audio is fine?
okay.
Yeah, it's come up now.
You know?
Yes, you are audible.
Okay, it's working, right? So I can continue. Good?
Yeah, thanks.
All right, okay. Yeah, so sheet metal is extremely cost effective for make large parts, right? And most of our robotic, actually all of our robotic teams are using sheet metal as the basis, right? So for example, the VIA bot, the first prototype was machined from CNC using ABS. And then when they switch to sheet metal, they have even these curvatures are able to do sheet metal, and then they saved roughly 3/4 of the cost to deploy. And then when they deploy to the customers, so the customer is one of the largest companies in the California, to swipe the parking lot, it's purely sheet metal in China, put on a boat, ship it to California, and start servicing their customers. So this is a fantastic way to make large robots. And same as extrusion, right? So extrusion, the die for the extrusion is extremely cost effective. So the tooling for the die, so if you're working with 2020s or 4040 extrusions, or for like, have this your own kind of a oval shape as battery pack, the die only costs around $500. So at $500, and you can extrude for such a long, nice shapes, very good materials, very good surface finish. It's very cost effective, right? The only problem with extrusion is that when you finish a die, most extruders, depending on the season, will require minimum amount of extrusions for them to load the die, extrude it, etc. And then for depending on what season it is, a lot of times it's 5 kilometers, right? So it costs more to store those extrusions rather than makes a die for extrusions. Okay, all right. So that's a very, very brief refresher on some of the tooling, methodologies or the manufacturing methods that our startups been using. I do want to spend more time on the injection molding part, right? Injection molding part is one of those factors that if you design it right, if you design correctly, optimized right now, that it will have a large implications in how much you can save down the road, right? So it is one of the most commonly used and cheapest methods for mass production. And then this is going to be a very brief introduction how to engage with the injection molding suppliers. Right. So I don't know how many in the audiences are concerned using injection molding parts or have experience with injection molding parts. But if you take a look at simple part like this, right? It's a cover. All right, it's cover roughly about this size. 100 millimeters probably across, and then if you like explode a bit with how much tooling, how much complexity goes into design tooling, you will see that it's actually quite complex, right? So a lot of different kind of metal components that goes inside that will enable the manufacturability of that part. there's a question about extrusion. I'm going to answer that first. So extrusion leads to a high degree of wastage, therefore overall increasing wastage. So extrusion depends on the material, right? If you take a look at the aluminum, the wastage is actually not that bad. Not because it's not wasting stuff, it's because of high recyclability, right? So aluminum, for example, I'm not sure the market rate right now, but there are times that people pay 85% to recycle of the virgin cost of aluminum to go back to recycling, right? So, for example, if you have a block, you machine the aluminum block, the shreds that goes out of it, people pay 85% of what that block, the virgin block, is for. So it becomes very cost effective. The extrusion, it will be significantly better in terms of how much that. Yes, aluminum alloy can be extruded. Actually, that's where all the examples on the previous slides, they're all aluminum extrusions. And when I talk about extrusions, I should mention that, but I'm talking about plastic extrusions. Aluminum extrusions. All right, cool. Okay, I actually do have a CAD drawing, and these are public files. So these are tools for some of my designs, and so and then you can download it, you can play around with it, and you can go inside how complex these parts are, right? So this is for USB stick here, like a grabber for the USB stick, and then you can see, even though it's a cavity of 4, you can see how many injection pins, how many glides, how many sliders, and all these kind of stuff will contribute to the cost of the mold, right? So, naturally, you'll be asking, if I want a tool, how much do I need to invest to design this tool? From the designing of the tool, right? So the good news is, your supplier designs this, right? In fact, that your supplier actually bakes this cost into the cost of the tool, and then the cost of designing a tool is so insignificant, it's usually a write-off from the supplier itself. So what's the point of this presentation, right? You might ask. And then it's because the design decisions you're making now will ultimately influence the cost and reliability of production, right? So what's any parts that you want to inspect and re-inspect before it sends to a supplier to construct a tool. So I want to reiterate this again. So when you have a plastic part you want to do injection molding, you actually do not design the tool itself, right? But you need to focus on the part itself. So you will minimize the complexity in going into the tool, all right? Does that make sense? Okay, so what are some of the design decisions you want to make now? So when the supplier designs a tool, you'll be at an optimal cost. Well, first, it's a couple of things, right? So cavity being one of them, right? How many cavities per tool, right? For example, in this case, it got 4 cavities, so 4 of these parts come out of it. So if you have 1 cavity, of course it's smaller, but you just every time you do injection molding, only 1 part comes out. Size, you also want to do standard mold sizes, right? So even if you do one part here, the mold might not be smaller because it needs to fit in a standard mold size. And then pressure, how much pressure it needs. Let's say a plastic chair will require very high tonnage of pressure, probably a 1,000 pounds, 2,000 pounds range, but a smaller one, like what you see on the right side here, probably do a very, very small 50-ton kind of machine, right? How many sliders do you have? Do you have overmold? The materials that all comes into play, right? So, spoke about cavity. How the molds are made are essentially CNC, right? There's some movements in having a 3D printed steel that goes inside to do the injection molding, but vast majority of the molds are made by CNC. And then when you do inspect a shop that makes a mold, that you see like there are lines of CNCs and EDM machines, right? And then you can tell a lot from the shop, and you can tell a lot how much it will cost based on the brand of CNC they have, right? If it's German-made CNC, you know it's going to be very expensive shop, right? So it's charged roughly 20 RMB per shop hour, where if it's Chinese-made CNC, it's the lowest run or lowest cost, it's roughly 100 RMB, right? And in between is Taiwan, American, Japanese in between, right? So if you want precise, good quality, you know the shop knows what to do. You're looking for German-made CNCs in the shop, and this is the same for Chinese CNC, Chinese mold shops, European mold shops, American Indian shop. So the hierarchy of quality will be indicated by the brand, right? The cost, of course, will be very different from each of these suppliers, but the quality of the shop and quality of expected quality of output will be on this side, right? EDM. So EDM is an interesting part. So EDM is surprisingly cheap. So what it is EDM stands for electrical discharge machining, I believe. And then essentially is to machine out elements. Actually, I don't think this part is EDM, but essentially it's a copper contact that move up and down very slowly, microns at single time, but it charges high amount of electricity, right? And then as it contacts the metal part, it just eats away with a bit of chemical. And then so it's very cost effective because the amount of work it goes into EDM machining part is manual labor is not that high, and the machine for EDM is quite cheap. So if you have parts that requires kind of complex geometry but at a small scale, EDM is the way to go. So on top of that, gun drills, which is where they do the cooling channels, is for the mold. That's quite expensive. There's some movement of 3D printing these molds, so you can have the internal cooling channels without using gun drills. But every time you load a gun drill, every time you do one of these holes, it's roughly 200 RMB. So it's like $30, $40. All right. So this is a very rough cost breakdown if you want to do this. If you want to do your mold in Guangdong area where Hack is located, most of the molds in the world are made in this area. So within 200 kilometers of where I'm staying right now. Doesn't matter where, if the mold is ended up in doing injection molding in America, in Europe, in China, a lot of the molds are made here. I used to own a mold shop in this area. Essentially, it's that you walk down a street and then there's like 50 mold shops on the left and right side. Okay, someone asked me to go presentation mode. Okay, there we go. Okay, all right. So there's some CMF consideration. So the way I mentor our startup is that, you know, it's making your product is one thing, and also you want to tell a story around a product, right? And then the maturity of the startups is most visceral on the object you can touch, feel, and interact, right? And that's where CMF comes into play, right? It doesn't matter you have the most advanced machine learning algorithms, machine vision algorithms. If you have a product that's that for your customer that is not that looks like it just come off FDM 3D printer, then you will bring a negativity to the perceived maturity of your startup. So CMF is extremely important. And then there are a few ways to enhance the design through ACM consideration. One of them is in-mold decoration. So that's going back to the 90s when our phones look like this. So most of these are through in-mold decoration, but these are extremely expensive. And if you go cheap way, you will get like cheap shapes like this. So that's not really recommended right now for startups. What is one of the things that is recommended is in-mold textures. So in-mold textures are essentially these kind of chemical etchings for the mold that ultimately creates these kind of textures. You see this a lot in automotive, fake lasers or kind of grips for power tools, and these are chemically etched, right? So you don't draw this out in CAD. You spec out, hey, I want a Yexan MT1120 kind of mold texture, and then they will buy this kind of buy the tools for this, and then etch your mold, and then when the mold goes in production, it will come out like this, right? So surprisingly, there's only like few big players in this kind of mold texture. One's Ixen and one's Motec. So when you do want to spec out mold texture, what you want to do is you want to spec out number. It's either from Ixen or Motec. Right? This one's Motec. All right, and the last one is two-shot, right? So you see this in toothbrushes, you see this in power tools. Essentially, it comes in two materials that's not assembled together after injection molding. It's actually injection molded at the same time, right? So this can create actually quite good effect, because that the part that you, for example, the tool here, the part you touch is kind of have a different kind of material as a part that's structural, right? So the mold for this is quite expensive, and tuning for this also require two injection molding kind of merge in the middle where the tools meet. So as you can imagine, it gets quite expensive, but have a very good effect. All right, so going to the last part, the last section of today's chat is how to engage with manufacturers. So this is the most important part of it, as comes from it's generated from the experiences I have worked with hacks. The previous couple of slides are mainly something that's in common to, I guess, engineering books, that it's mechanical engineering books. But how to engage with manufacturers is quite important, because manufacturers are your partner, potentially your first partner in your road to get your products out to the world, right? And then to have a good relationship with your manufacturer, to have a manufacturer understands you, and then is critical to success, right? You don't have enough money, well, at least hack startups don't have enough money to switch manufacturer once they start mass production, right? Because you have to make those sales, or else your runway is not enough to sustain a switch of manufacturer, produce again, and start selling again, right? You don't have enough time, you don't have enough money to do that. So if you look at the whole road to manufacture, right, it goes quite a bit of, on the left side, it's probably before, it's probably on the back of the napkin kind of way, and this is probably where you get your first set of investments, and then you are probably somewhere here, you're trying to do a custom development engineering spec, write some firmware, make it work like prototypes, and keep going in this hopefully not endless loop, but definitely have a couple iterations, and eventually you're going to reach an engineering prototype, right? And then going to EVT, that's engineering validation, that's probably going to be a look-alike, functions pretty much there, and then the software is working, it looks pretty much there, and then DVT, where the design also combines the engineering prototype. It's going to look at the material is pretty much finalized, and then the texture, the UI, UX, everything is good to go. And then you go to PVT. That's when the factory have a prototype line set up, and then they try to produce 10 or 100, and then before it goes to a mass production, right? So this is the light on the end of the tunnel, and then this is where everyone strives to be when you have hardware as part of the equation. So you are here, and when you look at this whole scope, right? And you probably have already met some, or heard about some, or know some manufacturers that actually can work with you in all of these spectrums. So if we break it down a bit, you see, you probably know, Apple, who is the most valuable company in the world, have a fantastic product line, but they have no factories. All right, they use Foxconn, they use Flextronics, and then I think they also just started manufacturing in India. They don't own any of the manufacturers, but what they do is that they contract this manufacturing out. right? And then if you look at the two edges, also two extremes, which is even more outsourced, right? So Apple makes a lot of the R&D internally, and it just manufactures, it just outsources the manufacture part. Where there's other companies that even outsource R&D part, right? So Juicero is one of those examples. Probably not the best example I can give, but Juicero is just outsourced everything on the left side, and then on the other side is that you have your own factory, right? So Xiaomi, for example, they have their own factory, and a variety of other companies have their own factories. These are the hack startups. Some of them you might know, some of you might not. That falls in the spectrum as well, right? So, like even as a startup, it's perfect okay to use the agency model or some even contract manufacturers, but also some of our startups have their own factories. There's a question somewhere. I'm just read this very quick. Oh, okay. Well, in the full screen, I cannot read questions. I'll come back to it. All right. So the first example is I want to give out is it's a full agency model, right? So right on the left, and then they takes care of almost everything, right? So there are some agencies that go from essentially right after you give them a back of napkin stuff, and then they can start designing, prototyping, researching, and then it can take to EVT. Some of it even goes into a little bit further, goes to mass production, right? So Fuse Project, for example, goes here. Fuse Project is the one that makes Juicero, and then Dragon Innovation, they do here, but they also have good relationship with a lot of manufacturers that go and take care of everything, right? So this is for two kinds of startups. One is well-funded startups where hardware is just needs to it's an enabling factor for software, with the most stuff is on the software side. And then you just don't want to take care of the hardware, like maybe a camera, for example, right? And where all other is a version 2 of a Kickstarter project. So two examples. So Fuse Project made this Juicero, right? So there's always a danger of disconnect between what the product is and what the customer actually wants. And in this case, I believe some part is in this case, right? Fuse Project made a fantastic engineering product that ultimately missed took a detour on the user requirements. So that's how the whole fiasco and ultimately leads to the failure of Juicero. And then other one is that Dragon Innovation made the Make Block replicator. I think it's the fourth one or third one. So Make Block 1 totally in-house, Make Block 2 totally in-house, and then until this version, replicator, it just outsourced everything. That's after the purchase of Make Block by Stratasys. So different ways to do this. So in this case, they already know the customer. They already know what the customer wants. So so it becomes a more straightforward exchange to the design agency. So most of the startups, though, will fall into this category, which is a full service contract manufacturer, right? So Apple does it, Jetta, Foxconn, etc., and then it goes to a smaller startups also is able to benefit from this. In fact, most of our consumer startups do fall into this category, and some of them do manufacture with Foxconn, some manufacture Flex. So Foxconn, Flex, those large manufacturers, even though they do serve Apple, Samsung, etc., they do also serve smaller startups. It's not the same factory; it's a much smaller factory, but you also able to benefit from that, right? And then it's great for easy hardware, difficult software companies, or if you are very well-funded startups, right? So CMs, full service CMs, just like the name suggested, is full service. So they go from the design the tooling, the simulating tooling, they go manufacture, they can also write firmware for your code, they do test jigs, they do EMS, they also, some of them even do certification, right? The injection mold in-house, and then it's pretty much like a city, a small city that's just a factory. They have schools, they have gym, they have dormitory, and you have a bunch of factories that's manufacture hundreds of thousands of products for around the globe. Right, so hack teams, most of them do use this because it's simply a one stream of service, right? Okay, so toll manufacture is for it's I call a subset of contract manufacturer. Essentially, they only take on your project when you have a look-like, work-like engineering prototype, right? So they don't do any kind of iterations. They have the drawings and they produce whatever's on the drawing. They don't do any modifications. Where full service CM will do a couple of iterations of this, right? So a lot of our teams in a difficult hardwares do take this route. So medical devices, industrial devices, anything with a heavy emphasis on dynamics, mobility devices will fall into this category. So toll manufacturers, you will see a lot of this. So they do have automation, but the final assembly is rather manual, right? Because the complexity of the product will require a bit more manual process, unless you have huge amount of orders. If you have looking at 10,000 units or so, it's probably going to be something like this, right? And the last one is just say, what's it? Give me 1 second. My daughter is 可以爸爸打电话，你可以去对爸爸打电话，你可以去看电视吗？看电视，爸爸没时间，好不好？好不好？爸爸没时间，你看电视，爸爸忙就好，半个小时，好不好？好，不要紧，你先继续看。Apologize. Having a daughter, 2.5-year-old daughter, while working from home is not the easiest thing. Apologize.
Not a problem. We face the same thing.
Okay, so for the factory, all right, someone else's factory, that's where we're thinking about this kind of specialized factory, right? So sheet metal factory is one of them. So a good example is this kind of sheet manufacturing factory. 1 second. Baby, 爸爸真的要去打电话，爸爸没时间，你看 YouTube。Okay, I gave her my iPad, so hopefully this will last for 30 minutes. Okay, so specialized factories are a kind of go-to place when your manufacturing method is dominated by a method, right? Your manufacturing process dominated by one method. So for example, a Oasis is a recycling machine that's mainly made of sheet metal. And then their factory, the factory that made everything, is just a sheet metal factory, right? So they're more than happy to take your electronics, assemble it in, like test it, paint it, and then during final assembly, if the majority of the work is their bread and butter, which is sheet metal, right? This is also true for a lot of robotic companies. So robotic companies, in the end, is just sheet metal with screwing some screws for the wheels, for the node computers, for the sensors, etc. And then sheet metal manufacturers more than happy to do this. So the last one is your own factory. So even though our startups are not well funded when they're at the hack stage, so most of our hack startups get roughly 250K when they arrive at hacks, and then they get potentially some follow-on funding right after they exit hacks, but they are still able to set up their own factory, right? So your factory, well, I put in quotes factory, is essentially assembly house, right? Because a lot of components you still do outsource, right? So PCBs, for example, purchasing the E components, it might go to an SMT factory, then goes to your house, goes to an in-house assembly, or you can even have a pick and place. Pick and place are quite cheap right now. So we do have I'm5 Stack, for example. They have their own pick and place. They have their own PCB assembly, doing PCBA in-house, and then they do the whole component in-house as well. So it's possible, but be very that this might in fact cost more than just using a factory. So this is what I'm going to about show once this YouTube loads is that PCBs that look like this. His name is Mario, and he's CEO of a company called Picno. This is his factory, right? Essentially, he just rented a tiny room somewhere in Shenzhen, and then just have their own PCB manufacturer, and have essentially ship their aluminum extrusions and ABS casings and a solar panel into their small workshop and assemble and ship it out, right? Why it's useful for them is because their devices are seasonal, right? So you might get an order every couple weeks, and then so it doesn't make sense to spin up a new line, which is CM, when the order is so unpredictable. So that's the reason why they create their own factory, and different startups have different reasons to create their own factories. So and it doesn't, what I just described is 4 or 5 different models that does not necessarily require to be either outsourced or in-house, right? And a lot of startups do, in fact, have some outsourced and some in-house. And then we have 2 examples here. One is a medium volume sports tech company, and the other one is a high volume audio tech company. Both are Hacks investments. They have a very different approach. Depends on your team's capabilities and depends on where your end customers are located and where the availability of resources are in the factory that they want to work with, right? So you can go many different ways. But choosing the correct partner in this is critical, right? So here is a very rough breakdown of the cost for when Bolt.io did to the cost of getting design, engineering, prototyping, manufacturing, etc. Right? I have to say this is for every project and every product is very specific. So this is a very rough, but take it as a relative term, not as a absolute value in these cost associations. Okay. Cool. So how do you select a factory, right? So the most important part is to trust your trust your network that have went through this before, right? So if you have another startup that have went through the same thing, if you have friends and family, do reviews, ask their customers, are a fantastic way to get started, and you absolutely must take these approaches when you set your own factory, right? And you also absolutely have to visit them, right? So when you do, yes, you're looking for a partner here. When you do visit them, there's a bunch of things you want to take a look at, right? So like there's two type of factory. One is like this, and the other one where it's a lot of very structured, integrated, and you know that it's going to get professional. But most of the factories you're going to visit is like this. Like it's a bit hard to see the quality when everything is like super manual. So you wanted to look for a couple of things other than the quality that this factory is going for, right? How empty are their lines, right? There's two-edged swords here. If it's very empty, you might want to understand, how come this factory doesn't make anything for anybody? If it's too full, that's also not a very good sign, right? Because very likely, at least for hack startups, Hacks is not the highest paying customer in their line, and then they have absolutely no guarantee that after this batch will it be able to make the next one, right? So they're not going to pay attention to you. And then if there's going to be a problem on the line, or it's going to be not enough, too many customers online, what happens? the startup get kicked out the line, right? So you want to find a partner that's right in the middle. Are they ethical, right? Do they have child labor in the factory? All the kind of stuff you want to consider, because at well, one, that you should use an ethical factory, and two is that if it's not ethical, there's always a danger of getting shut down by the government. Right? Do you have access to upper management? So this one is actually quite critical. So it doesn't matter how big the factory is, even the biggest one, you want to have access to the VP level or senior director level, right? Because when a problem occurred on the line, you don't want to work with up the chain to get to people who can make a decision, right? You want to get to that person immediately when you are making your 10,000 units of your product, right? So most factories will give you access to that, right? Unless it's way too big or their line is way too full. If you do not have access to it, take it as a bad sign. And do they take IP seriously, right? And this is very easy to tell when they bring you to their showroom, right? If you go to their showroom and you see stuff that it shouldn't be there, for example, if you see any Apple products, or if you're seeing fake AirPods in the showroom, you want to be very very considerate when you want to take them. And ultimately, is that you like them, right? Can you hang out them like as someone who you can how you feeling towards the person that's guiding you, right? Like are the other assembly workers on the line, like they are depressed? Are they happy? You know, do you have common interests? All those kind of things plays a role in ultimately how long your partnership lasts, right? Like if there is some problem happens in the line, will you be able to just give them a call and says, hey, you know, can you help me out and solve this? Or do you have to go with a very, you know, like climbing a ladder kind of channel, which is going to waste time, waste money, and ultimately going to delay your production as a startup? You just do not have time to do that. Cool. All right. Okay. So so when you're about ready to produce, when you're ready to start looking for factory, one of the things that you want is that you want to do RFQ package. RFQ package usually happens in a when your CAD is at a level that's ready to produce the first look-alike prototype. And then you do want to have your company's mission inside. Your rough funding status, you don't want to say, hey, we just raised a 2070K round for 10% of revenues. You don't have to say that. It just says, hey, we're a Series A company that's doing industrial robotics, right? What's done, what needs to be done, and we're looking for. Simple. So you do need a BOM list. This is after NDA, by the way, just in case you're wondering. And then you do need a BOM list, and the BOM list is going to be high value electrical components, and then the mechanical components, right? And then you want to spell out very clearly what testing you do, what certification do you need, and then the assembling and the sourcing process that goes alongside, right? Do you need to inspect every single component that's coming into the warehouse? Do you need to inspect every single component coming out of the lines, or do you do more of a spot checking? So, and you also want to have your schedule, right? So these are all in the RFQ package, and then so NDA first, or and RFQ, and then what they'll come back to you is a scope of work and a rough quotation. There's probably going to be some exchanges of clarifications in between, but what you're going to look for is a scope of work and rough quotation. And that quotation also spells how good the manufacturer is, right? If it's going to be a simple email that says, hey, this project is going to cost you 50K, you want to avoid that manufacturer, right? If it's coming a very, very clear scope of work and quotation, it says, hey, you know, like our factory is going to do X, Y, Z for you, and then the BOM, the cost is this, the markup is this, and then the lead time is this, and then we're going to do assemble, we're going to do certification, we're going to do verification, we're going to do 3 iterations for the PVT, and these are getting to a good and better side. So the more detailed the quote is, the more they pay attention to your work, and then finally do a PO and payment, right? It's very normal for them to ask for payments upfront, and depends on how much the tooling is going to cost and how much MRE is going to cost. Okay, so One thing you want to watch out for is that engineering, when you're going to make changes, right? Changes do happen. And then changes needs to be 100% recorded by something called an ECO, engineering change order, right? So you want to get a factory to acknowledge it, and you want factories to sign off on it, right? So even for a very simple, even typo, so in this example, it's a typo that caused a mislabeling of one of the components, and then require ECO to change it. Even for something as simple as that, you want a ECO, right? Because that the mistakes tend to compound, and you want to stop the mistakes at the root, right? So this is an example of ECO. When you Google ECO, you probably come up with a lot of it. And then the last thing you want to do is say you send them you call them up, say, hey, R2 just needs to change to change the stream value, and then hang up. And that's the worst thing that can happen, right? So even for the smallest things, do have an ECO. Okay, and then that brings us to the end of this presentation. We do have a next session, like Rakesh said, and then the next session is going to be a couple of things. So when you find a factory, when you have getting your product it's all ready to go, what are some things they want to watch out for? So it's going to be talk about QC, it's going to talk about test jigs, a bit more on documentation, factory etiquettes, and also how do you maintain the partner, right? Picking the partner is only half the battle. How do you keep each other happy? How do you not make enemies out of the people that's making product for you? It's going to be the next session, probably in a couple of weeks. All right, I'm going to close this. I'm going to minimize this so I can see the questions that was that's asked. Okay, let me pull this up.
Thanks, G, for this interesting session. A few questions which have been asked by the participants. Maybe you could have a look at that.
Okay, all right. So I'll start with the first one. So it's EVT, DVT, and PVT in detail, right? So yes, I can. So what Tusha, what's your product? What you making?
Tushar, you can type that in the chat box if you like.
Okay, while he's typing this out, yes, you can get this presentation later for review. I will share a copy with Rakesh, and then and you can help me distribute. Okay, so without knowing too much about what Tusha is making, I'm just going to give a very general answer to EVT, DVT.
Sorry, he's making an IoT product for automobiles.
Okay. So a EVT is probably at a stage when that had all the functions ready, and then you are testing the operation parameters for this, right? So EVT will probably involve your device be mounted onto the vehicle and then drive for, I don't know, tens of miles and see if it breaks. And it's probably going to be some, if it's IP ratings, you probably want to get test it with IP67, put it under water, put it under rain, see how dust's going to affect to it. Probably want to test the temperature, ranges, all those kind of stuff, right? On top, of course, the core functionality, but the core functionality is probably already tested as an engineering prototyping phase, right? So EVT is essentially also stuff like, if I ship this device through Amazon, if I drop my box from 2 meters long, 2 meters high, well, it breaks my device, right? So those kind of validations goes into EVT. And some certifications as well. Certification probably started here, but some of goes here, right? So DVT is the design validation. So design validation is quite similar to EVT, but it goes into a lot of your CMF factors inside, right? Like, does your the finishing on your aluminum, when you anodize it, does it look good? The fits between each of the components, is it okay, right? Are you using the right materials, etc. So those will fall on the DVT. The PVT essentially is that everything is ready to go, and then your factory set up a test production line, and then they start manufacturing, doing a test run, right? So in the test run, you would figure out, oh, hey, like so many cables, I need to, and then it's leading to me a failure rate because the cable pinch while I snap those two plastic pieces down, right? So we might need to change a bit of design, then do the revise the production. Or what stage do you do QC? Like how do you increase the yield? This goes into PVT. All right.
Got it. We have a question from Abhishek. He's asking, what is your view on regarding use of sheet metal components for mass manufactured consumer products?
Depending on the consumer product is, right? I mean, like if you're talking about a computer monitor, right? It needs to have sheet metal, right? If you talk about an iPhone, then it becomes a very difficult to use sheet metal to be a CNC, right? So it goes in both ways, and it also depends on the cost of the device. So personally, I like sheet metal because if you use creatively from the design process on, you can make very beautiful products, very well-made products for very cheap, right? Sheet metal cost is significantly lower than the CNC cost when you're working with metal. So if you use it right, I do prefer sheet metal, but sheet metal, of course, have a lot of limitations to the ultimate geometry, right? It's a planar kind of components, but this is something I do like when it's used right and when the time when the product allows. Okay. All right, moving on to the next question. Looks like I do probably have more questions that I can answer in the next 5 minutes. So I will keep going, but I'm more than happy to reply these answers. If you, Rakesh, you can give me if you can email me a list of answers, I'm more than happy to reply by email. But I will try to get as many as we can in the next 5 minutes. So Cohen's question, certification done by CM, and that depends on the CM. And also some certification can be done by you, right? So there are self-certified certifications, but certifications are usually done by certification houses. So someone like SGS, TUV, Intertech, those are probably have a bunch of those close to, doesn't matter where you are, it's probably one of those kind of certification houses within, I don't know, 1 hour drive of you guys. And then CMs also do certifications, but probably not some of the, for example, some very specific, right? So for example, ISO 13485 can be certified by CMs. This is a medical certifications. So only places that can do medical devices are certified to do that, right? And some of them have to be certified by CMs. Another one is ATAX, so explosive proof certifications. That can be done by CMs, but most of the CM certifications is done by Intertech, SGS, TUV. So certifications are accepted internationally. How long does it take? So certifications depends, right? So if you're looking at CE, it's only accepted in Europe, right? America have the UL and FCC. And Canada have something different, China has something different, India has something different, right? So the good thing is that if you apply for a equivalent CE and FCC, the certification process can be done in one go. So when you, let's say you approach SGS, says, hey, I want a CE, FCC for this device, and they'll do the test at the same time. And then how long does it take to obtain those? It really depends on what kind of certification you're looking for. But you want to reserve at least 3 or 4 weeks for something that does not have dynamic inside, but it's purely a FCC certification. Okay. All right. early stage consumer products optimize for molding cost during design? Yes, you do. So the first thing you want to decide is that if you want to go with what kind of a manufacturing method, right? So should you go with a sheet metal, with plastic body? And then if you do, and then you want to question based on the volume they're working on, do you want to go with injection molding, or do you want something with vacuum casting, or even 3D printing, right? So when you have when you choose mold injection molding, you absolutely have to design and optimize for the mold, right? Like I said before, that ultimately you're not the one who designed the mold, the injection molding factory is, right? And then you can add on costs when something doesn't make sense. So from the simplest things, that if you have a draft angle on your device versus a no draft angle device, is completely different cost, right? Even and this is something that you have to design it in. Okay, the next one. How difficult is it to injection mold parts which have features like width of 0.8 millimeters? I do not know without looking at the design. It is a lot more in play than just the feature width. So it includes the uniformity of the plastic, right? Is that only that part have 0.8 and everything else have 2 millimeters, or every single feature is 0.8 millimeters? That plays a different. How far is that away from where the injection comes in, and what kind of plastic is? Does it have draft angles? Is it able to, have eject it out without breaking? How much tonnage does your machine have? If you have a bit more detail, I'm more than happy to answer that with a more solid answer. Okay, next one. Machinery of vacuum and injection molding. I think Sega is saying that vacuum molding, right? You have CNC machine already. It's not even a question. Yeah, Sega, I don't think that's a question. I think it's a statement. So I'm going to move on to that one, to the next one. Ready for PVT? Yeah, so it depends on what pilot is, and then what modification do you need to do for the pilots, right? From at least from hacks companies, the pilot product is very different than the final mass product product, right? The pilot product, there's not a lot of optimization that's going on, especially for IoT, right? It just goes into, and then a lot of it is handmade rather than and produce. So the question for you, Anas, is that it really depends on how close your pilot product is to the one that's mass manufactured. But from my experience, most pilots have a lot of room to do cost optimization. Okay. All right. Unfortunately, that's all the time I have today. I do need to jump on another meeting right now. But thank you very much for all the questions and all the attention during my presentation. Rakesh, I believe that I have so many more questions I need to answer. I can do that through email, and maybe we will reserve more time for Q&A after the next session as well.
Sure, and I've then asked them to send the questions that they have to our email address, and then I can pass it on.
Okay. All right.
Thanks so much.
Fantastic.
Today, and we will get back for the next session maybe in 2 weeks' time.
Okay. All right. Thank you.
Thank you so much, guys. And I've shared the link for the feedback form participants. If you could fill that up, and maybe if you have, you can use that if you want to put any questions there. We could use that in collating all that and sending it off to you. Please put your email address as well in case you are asking those questions. Thank you so much.
All right. Thank you. Take care.
Thanks, GK.
Bye.
Bye.